In part 2 of this series, where we write Lewis structures for compounds having expanded octets, we ended off with question 3, where it reads, write the Lewis structure for H₃PO₄. If necessary, expand the octet on appropriate atoms to lower formal charge. So the molecule we're working with here is phosphoric acid, and it consists of 3 hydrogens, 1 phosphorus, which is the central atom, and 4 oxygen atoms. Let's go ahead and create the Lewis structure first. We have P, the least electronegative atom, surrounded by 4 oxygens, and there are 3 hydrogens bonded to the oxygens. Let's count how many electrons have been used up so far. 2, 4, 6, 8, 10, 12, 14. The total number of valence electrons that can be calculated by knowing what the valence electrons are for each atom. We have 4 oxygen atoms, and each oxygen atom has 6 valence electrons. 1 phosphorus that has 5, and 1, 2, 3 hydrogens. 4 times 6 is 24, plus 5 is 29, plus 3 is 32. And we'll subtract 14 from this, where we get 18 left. These 18 electrons will be distributed to the peripheral atoms. So starting over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now let's observe to see if each atom has a complete octet. This hydrogen does, this oxygen does, 1, 2, 3, 4, 5, 6, 7, 8, so does this, so does that, and so does this oxygen atom, except this one is problematic because, remember, phosphorus has 5 valence electrons, except here we have 1, 2, 3, 4. 4 electrons are being shared. So phosphorus should have an electron here, while this electron shouldn't be there. At this point, this does not have a complete octet, and over here we have 1, 2, 3, 4. That means 8 electrons plus 1, that's 9 for phosphorus. Now phosphorus can be hypervalent. In other words, it can have an expanded octet. And this is because if you take a look at the orbital diagram for phosphorus, shown right here, it has 3 d orbitals, which are not shown here, that are unoccupied. And as a result, this electron can occupy one of those orbitals as opposed to being here. As a result, phosphorus can have up to 5 bonds. And in our case, what we can do is take this electron and make them bond, leaving you with a structure that looks like this. Now take a look. This oxygen has a complete octet. This phosphorus has 10 electrons around it, and that's fine because of this situation. Therefore, this structure right here represents the Lewis structure for phosphoric acid. And there you have it. That is how to write Lewis structures for compounds having expanded octets.